All right, so the notes for 3.1 are about solving systems by graphing. For our class, when we talk about systems, there are going to be, there's always going to be two equations or two lines. And so when you have two lines, there's three different things that can happen. One of them is that the two lines can intersect at one point. And then the solution to the system is that point where the two lines intersect. If you have two lines, another thing that could happen is that the lines could be parallel. When lines are parallel, they never intersect, and so those lines would have no solution. And then lastly, the last thing that can happen is that the two lines can be the same line. They can overlap. Sometimes when that happens, you'll see that there's actually two sets of arrows on either side, kind of showing you that there's two lines overlapping with each other. And when that happens, we say that for the solution, we say that the lines have many solutions. So when we're going through and solving these, use the graphs below to state the solutions to the system, if any. The solution to the system is the point where the two lines intersect. So here they intersect once, here they intersect once, here they never intersect, and then here they intersect everywhere. So when we answer the question, anytime they intersect once, we're going to write the coordinates of that point. So for this first one, the solution to the system is the point 4, 3. That's the point where the two lines cross. On letter B, the solution to the system is the point 2, -1, because that's the point where the two lines cross. On example C, these two lines never intersect, so we say that they have no solution. And lastly, on example D, these two lines are the same line. They intersect everywhere, and so for this one we say that they have many solutions. Sometimes you want to check and see if a point is a solution to a system without actually having to go through and graph the whole thing. And so here they give us the point -8, +4. So this is your x and this is your y for the coordinates. And then they give us two equations for the two systems, and we want to check and see if this point is the solution. If this point's the solution, it means that that point is on both lines because it's the point where the lines cross. So I can put -8 in for my x right here, and I can put +4 in for my y right here and see if this point is on the first line. And then I can repeat that, and I can put -8 in here and put +4 in here and see if that point is on the second line. If it works out to be a yes for both of the equations, then it means that it's the solution to the system. And so what I've done here in this first step is I put the -8 in for the x and the +4 in for the y in the first equation, and then I went ahead and I put them where they're going to go into the second equation as well. And so I'm going to check the first one, and then I'm going to check the second one. Let's see. 1/4 times -8 is -2, and then -2 minus 2 gives me -4. And so for this first one, +4 does not equal -4, and so I put a little x next to this. What that also means is that I don't have to go through the process of even checking to see if it works in the second equation, because I already know that the answer to the question for this first one is no. That point is not the point where the two lines cross. If this one were to work, then I would go through the process of doing the second one, but because the first one didn't work, I don't have to go through the process of doing the second one because I already know that the answer to the question is no. So if this one did work, and if this one didn't, it would be a no. If this one didn't work, then you don't even have to do the second one. It would already be a no. And if they both work, then the answer to the question is yes. On the second example, on B, same thing. This is my x and this is my y. And I'm trying to check and see if this is the point where the two lines cross, but I'm trying to do it without actually graphing the lines. So I'll do the same thing in this one. I'm going to put my x in for my x, my y in for my y, and see if the first equation works. And then I'll do the same thing with the second one, substituting the x and the y into the equation to see if it's a point on that line as well. If it works in both of them, then the answer to the question is yes. So here in this first step, that's what I've done. I substituted the x in for the x in the first equation, and I substituted the y in for the y in the first equation, and I'm going to check and see if this works out to be correct. So 3 times 7 is 21, 2 times 6 is 12, equals 9, and then I'll add these together, so 33 is equal to 9, and that's not true. So again, on this one, since that does not work out to be true, I don't even have to bother doing the second one. I already know that the answer to the question is no. That point is not the solution to that system of equations. It has to be a yes in this one and a yes in this one for the answer to the question to be yes. When you solve a system by graphing, you're trying to take the two lines and you're trying to graph them to find the point where the two lines cross. If both of the lines start with y equals, it means they're both ready to graph. So on this one, this first equation right here, 2/3 x plus 1, this one's ready to graph because the y is all by itself. And then on the second one, y equals 5, that one's ready to graph because the y is all by itself. So I'll start at positive 1, and then for my first line, I'll count my slope. So up 2 and 3 to the right, and then up 2 and 3 to the right. And then I recommend that you go back to the y-intercept and you do the opposite. So the opposite of up is down, and the opposite of right is left. The opposite of up is down, and the opposite of right is left. It can be helpful to you to draw in all of the points that are going to fit on your graph. And so on this one, I was able to fit in points across the graph. Once you have those points drawn on, you'll connect them using a ruler or something to make a straight line. And once I have the first line graphed, I'll go ahead and graph the second line. The line y equals 5, 1, 2, 3, 4, 5, you go to where y equals 5, and then you draw a line that you can see. So again, using a ruler or a straight edge, I'll draw the line in here for where y equals 5. And then my answer to the question is the point where the two lines cross. And so for this one, that's 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4, 5. The solution for this system is the point 6, 5, because that's the point where the two lines cross. On example B, we're also trying to solve this system by graphing. The first equation's all set and ready to graph because the y is all by itself. But on the second equation, we have some work to do before it's ready to graph. We have to solve and get the y all by itself. So on the second equation, I'm going to minus the x from both sides. That'll turn it into negative 3y is equal to negative x plus 9. Remember, sometimes we cut the negative x in front of the positive 3 so that it's going to be in slope-intercept form. And then I'll divide by negative 3, divide by negative 3, divide by negative 3. So for this one, I'm going to get y equals positive 1/3 x, and then positive 9 divided by negative 3 will give me minus 3. I fix my second equation, and I get the y all by itself, because once the y is all by itself, that means that it's ready to graph. Once both lines are ready to graph, I'll start by graphing the first line. So I start at positive 1, and then my slope is negative 1. That's the number in front of the x. So I go down 1 and 1 to the right, down 1 and 1 to the right, and then I'll continue that pattern. And again, you're welcome to draw as many points as you can fit on the graph. Technically, you only need 2 or 3 points to graph a line. Some teachers recommend 5. I think when you're graphing systems, it's helpful to put a bunch of points on the graph, because now, when I graph the second line, I'll know where I'm aiming for in terms of a point that I'm going to hit. When I graph my second line, I'll start down here at negative 3, and then my slope is up 1 and 3 to the right. Ding, 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 winner, winner, chicken dinner. That point right here is going to be the point where the two lines cross. You can put another point or two on the graph just to kind of see and continue the pattern so that you can see where the graph goes. But this point right here is the point where the two lines cross. So you'll use a ruler or a straight edge to draw the lines through each of the sets of points. And then remember, your solution to the system is the point where the two lines cross. So for this graph, that's 1, 2, 3, and then down 2. So the point that's the solution to this system is the point positive 3, negative 2. That's the point where the two lines cross. Example C on the notes has the most work out of the 3 so far, because on this one, the y is not by itself, and on this one, the y is not by itself. So I'm going to have to do the work for both of those to solve for y to get them ready to graph. So I've written both equations down. To get the y all by itself on this one, I'll start by subtracting the 4x from both sides. So 2y equals negative 4x plus 6, and then I'll divide everything by 2. So my first equation, when it's ready to graph, is going to be y equals negative 2/3 x plus 3. Now this one's ready to graph, and then I'll do the same thing down here for my second equation. I'll subtract the 3x from both sides. That'll give me negative 3y is equal to negative 3x plus 9. And then I'll divide everything through by negative 3. And so I'll get y equals positive x, and then positive 9 divided by negative 3 will give me negative 3. And now this one's ready to graph as well. So you have to get the y's all by themselves, put it in slope-intercept form in order to be ready to graph both of the lines. Once both of the lines have the y's all by themselves, then they're ready to graph. I'll start by graphing the first line. So this one's going to start at positive 3, and then my slope is negative 2. So down 2 and 1 to the right, down 2 and 1 to the right. And again, you can continue that pattern You can also go back to the y-intercept and continue the pattern opposite if you want to. So here's the equation of my first line. You can draw the line now or you can draw the line later, either way. Some people think it's easier to draw the line first through the first set of points before they graph the second line. And so I've gone ahead and drawn that line. Now I'll graph my second line. So this one starts at -3, and then my slope is +1. So I'll go up 1, 1 to the right, up 1, 1 to the right, and then that's my point of intersection. Again, you can continue a couple points if you want to, but really you don't need to. Once you find the point where the two lines cross, you can stop at that point because you know where the intersection point's going to be. You go ahead and use a ruler or a straight edge to connect these points together, and then the solution for this one is going to be the point 2, -1, because that's the point where the two lines cross. So for these last two, the process is the same. We just have to practice an example of what happens when it comes out to be either no solution or many solutions. And so looking ahead to the first problem, this y is not all by itself and this y is not all by itself. So I'll start on both of these by solving and getting the y all by itself so that they're each ready to graph. So going ahead and solving both of those equations for y, for this one you'll get y equals 2x minus 5, and for this one you'll get y equals 2x minus 5. And so that's your first clue that something about them is going to be different. We'll start at -5, and for my first line it's up 2 over 1, up 2 over 1. That's my slope. And you can continue that as it goes across the graph. And then back to the y-intercept and opposite to get the other side of the graph right there. And so that's the equation for your first line. You can go ahead and connect that using a ruler. What's different about this graph is that the second line is the same. They're both exactly the same. So when you graph the second line, the points would be in exactly the same spot. You can put the double arrows on either side to show that there's two lines here. And the solution to this graph, so when the lines overlap everywhere, we say that the solution is many solutions, because every point is a solution to this one because the two lines cross everywhere. That's always going to be the answer when the two equations are exactly the same. And last but not least on this one, there's two lines to graph, and notice that both of them have to be fixed because on neither of them is the y all by itself, so we'll start again by doing that. So on this one, when we solve to get both of the y's all by themselves, my first equation right here is y equals 1/5 x plus 1, and then down here for the second one, when you get the y all by itself, you get y equals 1/5 x minus 2. And so the fact that the 1/5ths match each other is your hint that this one's going to be a little bit different. It's not going to be the same as example A was, but it'll still be a little bit different. So for my first line, I'll start at +1, and then I'm going to go up 1, and 1, 2, 3, 4, 5 to the right, and then down 1, and 1, 2, 3, 4, 5 to the left. And so that's the equation for my first line right here. You can use a ruler to draw the line that goes through those points. And then for my second line, it starts at -2, and then the slope is also up 1, and 1, 2, 3, 4, 5 to the right, and then you can go down 1, and 1, 2, 3, 4, 5 to the left, and then you can use a ruler to connect those points. What makes this problem different than the previous one and different than the other problems is that these two lines, they have different y-intercepts, but they have the same slope. So they're always going to stay exactly this far apart from one another. They're never going to cross. Anytime you have two lines that are parallel, the solution is no solution, because these two lines will never cross, so there will never be a point that's the answer to the question. They'll always be parallel, they'll never cross, and so they have no solution.